we have to represent above image creator. We have to create a kernel to detect 45-degree lines using convolution, apply to the car's image and plot the result. Now how we do is my kernel np array, and this will help us. We have to transform it to 45-degree, so this will help us to transform the to 45, and then when we run this, we have to run by plotting I am sure. Now we have to create a kernel to detect 135-degree lines using convolution. So same way we have to just write, we have to transform it to 135-degree instead of the above denomination. Now apply the following conditions to your image. Now how to apply the kernels, edge kernel. This way we can apply for transform edge to the 2D kernel, and this will help us to transform edge. The same way we are doing now, we have to transform the way, like if what color we want to take, gray or into 2D dimensional or any dimensional, we can do like this way. Same way we are importing again the libraries. Now we are creating a data set. Load the data set. How we load the data set? By training and testing images, and one hot encode target values, train labels, test labels to categorical, and convert from integers to float. How we convert the integers to float is this way. For now we are normalizing to range 0 to 1. Now how we can create the model is where we can, through keras or sequential, it will help us to create the model compilation. Model dot how to compile model dot compile will help us to compile the model. Now we have to display summary of the model. How we display model dot summary. Now we have to create a custom callback class to be called during the training. How we do is class, you're taking a custom callback. This will help us. The epoch run, instantiate the custom callback. How we instantiate is cc is equal to custom callback. Now we have to train the data, train the network. This will help us to train the network. It does take time, but when you use the runtime and then when you change the runtime to GPU, this will help us run very fast. Like this will save your time. Define a function to plot the result. How to plot? We have to define now. So we are using def. Now call the result plotting function. How we call is result plotting, and then this will help us to result. Now we have to answer different question. Did the network presented signs of overfitting? Yes, we did. And then write down how many layers we had. 5 layers. Now we have to explain what is the purpose of each of those layers, what role does the each layer play. Now we have to add one more convolution layer to your model and run it again. To do that, type your code. We have to just using the same thing. We are just adding one more thing. And then the same way, and then for calling result, we have to result plot. Now we have to compare it. How does the comparing work? Compile, we have to compile it and then again train the data, and when we train the data, it will help us in result plotting. And that was all for today. Yeah, and we have to again do the same thing with different activation and optimizer. So this will help us to give an accurate result, and this will help us to train the result. That was all for today. Thank you.